So far we've talked about Java string methods, and now we're going to complete a project called DNA sequencing. So it's telling us a little bit about what DNA is and what it's composed of. And essentially a strand of DNA could look something like this. Now it says to write a DNA.java program that determines whether there is a protein in a strand of DNA. Okay, so a protein has the following qualities. It has to start with ATG, so a sequence, okay, in this strand, what they call a strand, has to start with ATG and has to end with TGA, and the sequence in between the start and the end of the strand should be divisible by 3. So divisible by 3. Okay, now we're gonna have a look at the tasks and start completing them one by one. Here in task 1 we have a reminder of the string methods available to us from the string class. So we've seen them in the previous video: the length, the concat, equals, index of, char at, substring, to uppercase and to lowercase. And what I've done, I've added them here from line 10 all the way to line 17, just so we have them handy. Okay, we can take this one off. Setting up. So in task number 2, it says, let's create a skeleton for the program. Add the following into the DNA.java file. So just to add this thing, which I've done already here. It's just a comment that shows us some sort of a DNA sequencing. Okay, on task number 3, it says write a comment near the top of the program that describes what the program does. I've kept it really simple. Here on line 2, I've added a comment that says DNA sequence project. Okay, we can take this one off as well. If we have a look at task number 4, it says there are 3 DNA strands that you're going to use to test your program. So these 3, okay. Store them in different strings, DNA1, DNA2, and DNA3. So we have to create a variable called DNA1 of type string, to which we add this value, and then we continue creating a variable of type string called DNA2, and we add this value, and then we do the same for DNA3, and we added this value. I can take this off because here on lines 24, 25, and 26, I've done just that. I've created the variables DNA1, 2, and 3 of type string, and I've added their values here, okay, being these ones, 1, 2, and 3. Okay, in task number 5, it says to create a string, a generic string variable called DNA that can be set to any DNA sequence, and these being DNA1, DNA2, and DNA3. So what I've done here on line 28, I've created a variable called DNA of type string, and I've added, let's say, DNA1, okay. We can take task number 5 off as well. Let's have a look at number 6. It says to warm up, find the length of the DNA string. Now on line 30, I've created a variable called length, and of course it's going to be of type string, and here we're using the DNA, so our variable, and we take its contents and we run the length method, okay, the length string method. And this one is going to give us the number of characters that our variable is storing inside, okay. In our case, this should be, well, let's see if we're going to print it. Let's comment these out. And if I'm going to run it, length is 15, because so this output here is the result of line 32, where it says system.out.println length plus length. Okay, so length is the number that this method run on the DNA is going to return us. And that gets stored into this variable called length. And then we use the concatenation here on a string with a number. Okay, so therefore we have 15 on the screen because the length of this value here, of this string, is 15. Okay, we can tick this one off as well. Let's find the start codon and the stop codon. So in the previous tasks and in the definition of the exercise or of the project, we've come to the conclusion that a start codon must be these letters ATG, so this sequence, and the stop one should be TGA, okay? So if anywhere in our value, our code is gonna find a sequence, so somewhere in here, it doesn't have to be necessarily at the beginning, but if somewhere in here we have a sequence that starts with ATG and a sequence that ends with TGA, and then in between them there's a number of letters that is divisible by 3, so the sequence that is in between ATG and TGA, if that sequence is divisible by 3, then this should make it a protein, okay? It should make it a protein. Alright, so remember that a protein has the following qualities. It begins with a start codon ATG, okay, which is this one. It ends with a stop codon TGA, which is this one. And in between, the number of nucleotides is divisible by 3. Of course, try and just ignore all these like fancy scientific terms, codon, nucleotides, and so on and so forth. It's a bit tricky for someone that hasn't had any contact with these terms or with this field, you know, to understand. But let's just try and work the best we can. Okay, so it has to start with ATG, it has to stop with TGA, and whatever is in between ATG and TGA must be divisible by 3. Okay. Okay, so let's start with the first condition. Does the DNA strand have the start codon ATG within it? Find the index where ATG begins using index of. Well, we're going to use the index of course, on our DNA, okay? But we know that we are containing this DNA, DNA1, DNA2, and DNA3. We're going to put them in turn in our variable called DNA, just a generic term, okay, DNA. So at this point, we know that DNA is a variable of type string that stores our DNA1, okay? Let's think that we're only working with this one for now, okay? We have to find a way to determine whether somewhere in this sequence there's a small fragment that starts with ATG, that ends with TGA, and in between whatever number of letters is there is divisible by 3. To do this, we have to find the index where ATG begins, if there's any, okay? And for this, we're going to use, of course, the index of, and we're going to pass it as an argument our start codon, because we have to, this is what we have to check for. Let's see if there's somewhere in here a sequence called ATG, okay? In this same exact sequence, ATG, okay? And for this, we're going to use the index of. If there's none, it's going to return us -1, okay? And if there is some, it's going to tell us exactly what is the index where that sequence begins. So ATG, it should be this one. So in our case, our index should return 0 because it starts at 0, okay? At index 0, ATG, okay? We have it here. The same way, we will have to check whether the stop codon is there. TGA. So we'll have to use the same index of to find whether there's a TGA in there, okay? And in this case, it's gonna give us the index that starts here. Okay, so given that the whole thing is 15, yeah, is the length 15, the number of characters in here. If it has a length of 15, we know that the last index will be the length minus 1, simply because everything, any counter in programming starts at index 0, okay? So this would be index 0, and this would be index of length minus 1. So this would be index 14. This is index, oops. This is index 13, and this is index 12, okay? So whenever we're gonna look for this TGA, okay, so the stop codon, the end codon, by passing it as an argument in our index of method, is gonna return us the index the index, what did we say? The index 12, okay, because this is 14. The one in front of it is gonna be 13, and the one in front of it is gonna be 12. Okay, so 13, no, 14, 13, and then 12. Okay, this one. That is gonna be 12. All right, so what do we need to do here is we have to create a variable of type int that is gonna store where the start codon starts, yeah? In our case, this is gonna be found at index 0, so it starts at index 0, okay? If we're gonna print it here, we should get on the screen the start index of this sequence, ATG, which we determined that is gonna be 0, okay? If I'm gonna save it, so we have the length 15, which is the result of line 32, and then we are printing out on the screen the start variable, which it contains the start of this sequence, the ATG sequence, okay? Since DNA here contains DNA 1, yeah, is looking into this value, and it determines that, okay, this sequence, ATG, starts at index 0, okay? That is task 7. If we have a look at task 8, it says, next, does the DNA strand have a stop codon TGA? So now we have to check for TGA. We can do the same thing. We can create a variable of type integer called end, and we say DNA, okay, which contains our DNA 1, this value, go and find me if there is a TGA sequence in this value, and return me, so give me back the index where that sequence that I'm looking for, it's starting, okay? And in this case, we're gonna also print, okay? So on line 38, we're printing the end, okay? Because the end is the name of the variable where we are storing the result or the index that is gonna be given to us here, okay? So give me the index where TGA is found within this sequence. If I'm gonna save it and run, we get 12. This is because, like we discussed before, is going to look what index is this TGA starting? Well, it starts at index 12, okay? Okay, so we've done task number 8 as well. Now let's find the protein, okay? So let's start with an if statement that checks for a start codon and a stop codon using the double ampersand here, sign, which is the AND operator, okay? So we have to check for two conditions. Does our sequence, our big value here, does it start with ATG? Yes, it does. So ATG, where is it? ATG is at the beginning here. and then go and check as well if it ends with TGA, okay? So we have to check for two conditions, and for that we have to use the AND operator, okay? And for this, what I've done here is this code, okay? We know that if this is gonna return that, well, I can't find any ATG, then it means that it will return -1, okay? So therefore we're using this knowledge that we have, so the -1, and we say, we check here, is my start -1? So if the start is not -1, meaning that if the start does indeed find me an ATG sequence within this value, and so that was the first condition. And check me as well if the end is not -1. So if the end is indeed TGA, okay, let's ignore this part for now. So if those two are good so far, then it means that we are already satisfying the two conditions, okay, which is, yes, it has an ATG start codon and it has an end TGA end codon, okay? But now we also have to find if what is in between, so the rest of the sequence, is of a length that is divisible by 3, okay? And to do this, what we have to do is we have to check for this condition as well. So of course we'll have to use an AND operator again. So we have to say end. So if the end, so wherever the end, which is 12 in our case, if 12 minus the index of the start, okay, this is how we get the middle of the string essentially, okay? If 12 minus 0 is divisible by 3, and how we do this, how we check this, is by using the modulo operator, which gives us the remainder after a division. So if 12 divides 3 without any remainder, which is, this is what we're checking here, then it means that this is going to be true, this is going to be true, and this is going to be true. Therefore, go here, okay? And print on the screen, okay, whether it has a protein or it has no protein, okay? So here it reminds us that the index of string method will return -1 if the substring does not exist within a string. Okay, so it's exactly what we have seen here. And that -1 is what we've used to check our condition, okay, in these two statements here, in these two expressions. Okay, so we've done task number 9. Now in task number 10, it says add a third condition that checks whether or not the number of nucleotides in between the start codon and the stop codon is a multiple of 3. And this is exactly what we've done here. So go to the index where the end codon starts minus the index where the start codon starts, okay? And if that number is divisible by 3, meaning that the modulo result should be 0, if that is the case, then we have a protein, okay? So if it satisfies the condition of starting with ATG, ending with TGA, and whatever is in between ATG and TGA is divisible by 3, okay? We've done this one as well. So now it says on task 11, it says inside the if statement, create a string variable named protein. We've done here. So we've created a variable called protein, and the type of the variable is of type string. And now we're going to use the substring method, okay? And the substring method can take two parameters, one being the start index where we want to start, and the other one would be the end index, okay, where we want to end. So say in this string, if we wanted to start at 0, okay, and end at the end, we would give it start at 0 and end at 14, okay. Fine, so it's a substring that starts at start, which in our case it's 0, and it ends at the very end. And our end was this one, where the end will give us the index where TGA starts, and in our case is 12, plus 3, okay? Because 12 plus 3 will be the length, okay? The exact length of our given string, okay? So then this protein is gonna take this result here and is gonna be concatenated with the actual text called protein, and we do concatenation plus whatever the value of protein is going to be from here, okay? So from line 42. Now, if this condition is gonna be false, then say no protein, okay? So in this line, in line 14, we're checking, does it start with ATG? Check also if it ends with TGA, and also check if whatever is in between ATG and TGA, whether it's is divisible by 3. If that is the case, then create me a string called protein, and inside the string put me the substring from our text, okay, which is gonna start here and end here, okay, and then print me on the screen the protein inside this sequence, okay. Also, if any of these expressions are gonna evaluate to false, then the whole thing is gonna be false, because if you remember with the AND operator, all the expressions must be true in order for the whole thing, the whole code to be true, yeah. So if this is true, then do this. If this is false, and this will trigger false if any of these are false, okay, then print me no protein, okay. So we've completed task 11 as well. We've completed task 12 as well, because we've added the else clause, which says no protein, okay. And now if we're gonna run it, let's have a look at the other result. So length 15, like I explained before, it comes from as a result of line 32. We're printing out on the screen the length of whatever value we have here. So we have the DNA variable that stores this one, okay? Fine. Then it goes in here and it checks, does it have somewhere in here a sequence that is ATG? Yes, it is, okay, which starts at index 0. Does it have somewhere in here a sequence that ends with TGA? Yes, it is, okay. And then if that is the case, check also whatever is in between, if whatever is in between, the length of whatever is in between is divisible by 3. In our case, yes, it is. And it's gonna create a string, and it's gonna store it in this variable called protein, okay? And the created string will be a substring that starts at the start, so at 0, and ends at 15, okay? And this is our whole protein, okay? So ATG, CGA, and so on and so forth, and it ends with TGA, okay? Now let's try it, which, by the way, which here in task 13, it says that yes, it should contain a protein. So yes, we do have a protein, okay? Let's try now with the DNA. So with this example, with DNA number 2, let's see if we have a protein. So it says no protein, okay? Let's check why. So does it start with ATG? Well, we do have an ATG here. Does it end with TGA? Well, yes, it does end with TGA. So those two, so this one, this condition and this condition are both true. So far so good, okay? So this is starting with ATG, it ends with TGA. But let's see what happens in between, because obviously this must be the condition that returns us false, okay? So let's see that whatever is in between, if whatever is in between is a multiple of 3, okay, is divisible by 3. So let's see how many letters have we got in there. And I've just made the font a bit bigger. So we have 1, 2, 3, 4, 5, 6, 7, okay? So of course 7 is not divisible by 3 because we would have a remainder of 1. So therefore this condition here is going to give us false. If this is false, then everything is false, okay? Because we're dealing with the AND operator. Therefore, instead of executing this code on line 42 and 43, it's going to go to 44 to the else clause and it's going to say no protein, okay? Which we have here as well. And of course, it says that DNA 2 does not contain a protein, okay? Now let's check with DNA 3. DNA 3 apparently contains a protein, okay? So let's have a look why, okay? It's going in our code to check whether we have an ATG, okay? Do we have an ATG? Yes, we have. ATG starts right here, okay? So a sequence within our whole value here. Okay, so far so good. It did find a starting codon of ATG. Let's then check if it has an end of TGA. Does it end with TGA? Yes, it does. Okay. And now also, let's check how many characters are in between ATG and TGA. Okay. So this is where we start. This is where we end at TGA. And in between, we have 3 letters. Okay. 3 characters. Is 3 divisible by 3? Yes, it is, which makes the third condition as well true. So this one was true, this one was true, and now this one is true as well. And of course, if all of them are true, then the whole expression is going to evaluate to true, is going to create our protein variable, is going to create a substring that starts at our start, which in this case is 6, because this is the index where our start codon begins, okay? So 0, 1, 2, 3, 4, 5, 6, okay? And that is the A where the ATG sequence, so the start codon begins, okay? So that's why we're getting 6 here. And of course we're getting 12 because 12 is the start index where the ending codon begins, TGA. That's the index 12. And then it says, give me a substring that starts at 6 and ends at 12 plus 3, which is 15, okay? And then that sequence is going to be our whole protein, okay? So this one, ATG, TAC, yeah, TAC, TGA. So in our case, this was the start codon, this was the end codon, and in between whatever we have, these 3 letters should be, or however many we would have, should be a multiple of 3, so divisible by 3, okay? And therefore we're getting protein and the result, okay? And this is the the project called DNA sequencing.